All right, this unit we're going to talk about Earth's drifting continents, so we'll be getting into tectonic plates and so forth. For lesson 1, you're going to describe the evidence for the theory of continental drift and explain what Pangea is and why it's significant. So, plate tectonics. Earth's land masses resemble pieces of a giant jigsaw puzzle. The activity that you'll be doing or have already done should have demonstrated that because you can bring them all together. So the east coast of South America matches up with the west coast of Africa. That's one of the things you would have noticed. The Arabian Peninsula and the northeast coast of Africa, so right here, those match up. There is a waterway in between them, but they do match up pretty well for shape. Places far from one another with different climates have the same type of ancient organisms. So the fact that we find fossils in completely different continents that aren't able to travel to across the ocean or to those continents in any way, shape, or form suggests that they had to have been closer to each other when they were alive. So evidence of fossils of plants and animals that could not cross an ocean are found in both continents. That's something that they tried to figure out. How do you describe it? So one theory was that a land bridge once stretched across the Atlantic Ocean and connected South America to Africa. So what would have happened to that now? They figure that the land bridge sank to the bottom of the ocean. However, we talked about isostasy in the last unit, and that does not support this. The continental crust cannot sink into denser ocean crust, so it can't just fall down. But that was one of the theories that was supposed to explain this phenomena. Possible theory number 2, the Earth once had a single landmass called Pangea that broke into pieces. This theory was supported by research from Alfred Wegener. So those are two of the theories that explained why the fossils of plants and animals were on different continents with an ocean between them. Okay, so we've got the theory of Pangea. Alfred Wegener was a meteorologist. So he wasn't a geologist that studies Earth. He was a meteorologist that studied weather. But he made a bunch of observations and came up with this theory of continental drift. And continental drift suggested that continents had been joined together as Pangea and then have moved apart since. So he believed that our Earth started out such that all the continents were connected in one large landmass. Now, this contradicted widely accepted ideas about the evolution of Earth. People had other ideas. This did not support that. So people thought continents were permanently fixed, that they could not move, which, if you think about it from a logical standpoint, like, how are these giant land masses going to move? Like, they're so massive. You had to have an explanation to explain it, and Wegener did not have the capability to explain what was causing it, and nobody believed him. But 30 years after he died, evidence was collected that convinced scientists that he was right, that the continents can move. But when he initially brought it out, and this happens to a lot of scientists, is that when he initially presented the idea, nobody believed him. Okay, so we have evidence of fossils. The Glossopteris is an extinct plant, and right here is a fossil of the Glossopteris plant, the leaf of it. It's found in rocks in South Africa, Australia, India, and Antarctica. And if you look at a map, none of those continents are near each other. The seeds are too large to be carried by wind, especially across an ocean, and they're too fragile to survive an ocean trip. So the odds of them going from one continent to another, pretty slim. There's presence of Glossopteris fossils in frozen Antarctica, and that suggests that the climate must have been much different than it is, because if there's a plant fossil there, like plants you're not really going to find in Antarctica, it's way too cold. So the fact that this plant existed on multiple continents, and especially in different climates, like current climates, it supports Pangea. Evidence from rocks. When pieced together, mountain rock formations in South Africa line up with mountain rocks in Argentina over here. So these rocks are the same type of rocks. If you bring these continents close to each other, they match up pretty well. There are coal fields in Brazil that line up with the identical coal fields in Africa. So our coal deposits, I don't think they have those marked for the Brazil and Africa one, but we do have some coal mines that would line up if you were to bring those two continents back together. Rock deposits from glaciers are similar in South America, Africa, India, Australia, and Antarctica. So that suggests that those continents would have been near each other because it suggests that it was all from the same glacier based on the rock deposits. Okay, so glacial deposits found in areas with warm climates. That suggests that those areas were once part of landmass near the South Pole, so they would have had to shift locations. There are limestone deposits from coral reef found in Michigan and western Texas and other locations far from the equator, but most of our coral reefs are along the equator. So if we're finding them up in Michigan and western Texas, like those aren't typical places for coral reefs. Coal forms in swampy areas and found in Antarctica. So Antarctica definitely is not a swampy climate. So all of these pieces of evidence suggest that the continents were not where they currently are.